Okay, I get a red icon at the top that says I'm live on YouTube.
I think it's because you created this Zoom workplace, so you have permission to create this YouTube sharing. Yeah.
Anyway, I'm it worked now, so I'm going. Yeah, but they told me that the rights will be transferred. Anyway. Okay, someone of you has the video running and has their and we have the echo now. Can you turn that off, please? So that the YouTube, turn the YouTube off. Oh. Okay, so this is my first time live streaming on YouTube, and I'm already identified myself as a technical idiot because it was me who had the video running. All right. So for everyone out in the world who is seeing us now on YouTube, we're still in the preparation for the next session.
Interesting.
And struggling with the video stuff. So everyone who is here now in the session, be aware we're live on YouTube now, so the whole world can watch us seeing making fools out of ourselves like I just did.
Wolfgang, how easy is to do the live streaming on YouTube connected to the Zoom?
It's easy if you know how to do it and press the right buttons. But like you saw, yeah.
Right button?
If you don't know it, you can still go wrong. So let me hand over to Su Chen again. Make you the host. Good. So you will be the host managing the technical aspects. Jonathan will be the session chair. We're waiting for our keynote speaker. I only have email contact with him. Jonathan, do you have direct contact with him somehow via Slack or WhatsApp or so?
No, sorry, just by email.
Yeah, no worries. I mean, he will, like I said, for him, it's 2 o'clock at night, so he will join later anyhow. Good. So we still have 5 minutes before the session starts, and maybe also then people will pop in. Like with a real conference, it always then you wait a few minutes till everyone comes in. So for the people who have not joined us for the first session, we already had the first session. It was really good and interesting session from the papers. Technical setup, of course, yeah, first time a little struggling with. We're all used to Zoom meetings now and all kind of online chats after 9 months of pandemic. But of course, if you're hosting a webinar and there are multiple speakers and a lot of attendees, it's also, of course, a little different. And this is actually also noticed that if you have if you're using those video chatting tools for a while, and then you suddenly use a different one, or you always use a regular Zoom room and suddenly you have to use a webinar, it's sometimes you feel like you're even more clueless than when you used it for the first time, because you're always looking for the way how it is, and then the button is a little bit somewhere else and you're like, what's going on here? But anyway, we will manage. Good, so I can already put on some slides here. For that I need to share my screen. Yu Cheng, the Zoom stream is already live. I started that, but you have to start the recording. The session will start in a couple of minutes, but I think you can already start the recording now.
It looks cool. It looks cool, Wolfgang.
You mean the live stream on video on YouTube? Yeah. So my colleague posted in the panel, I shouldn't be too hard on myself. He knows that I have a reputation as perfectionist, so it will never be good enough. Anyway, Tsuchan, are you here?
Yeah, I'm here.
Yeah. Can you start the recording?
Now, okay.
Yeah.
Okay, it's recording now.
And you also have to enable sharing screen for me, because
okay.
I need to share my slides for the opening.
A second. Let me find that sharing screen. Sharing.
Xiang, do you know how to do that? It looks like Tsuchan is looking for the right button.
I found it.
You found it. Good.
Yeah. Well, actually, Yuzen is physically nearby me.
I got it. Yeah.
And I helped him.
Yeah, I got it. I just need to find the right window to share, because this is the right one, right? Can you see it? Session 1 has ended. Session 2 will start soon. That's the slide. Can you see the slide?
Yes, I think I can see the slides.
All right. Yeah, I see it now. I also found the chat window now. Good. All right, it's 3:45. Well, we have almost 50 participants. That's great. Let me see. So let's wait a few more minutes while I'm browsing the list of participants. I'm looking for Phil. Yeah, Phil is here. Can you promote Philip Shu to panelist?
Okay.
Okay, perfect. Yeah. So.
All right.
I did it.
Yeah,
it's okay.
hi Phil. Yeah,
he should be here.
Great. I mean, normally you do this stuff in the background, but I think it's not really. It's quite nice to talk with this and people are listening to it, because otherwise you just see an empty this plain slide and nothing is going on, and you're waiting. What are they doing? Is it going on? You don't know that behind the scenes they're struggling with the chat. Good. So 47. Let me have a quick look. Jonathan, could you have a look at the participants list while I'm talking to see once when Mark is arriving and is then making sure that he's promoted to panelist? Because when I will give my talk, of course, I cannot. Oh, Mark is here. I see him in the list of attendees. Okay, great. Then let's wait till he gets promoted, and then we will start. Did you promote him? I don't see him yet in the list.
I'm sorry, who?
Mark Billinghurst, the keynote speaker.
Yeah.
Without him, we're lost.
Usually you can find Mark in the attendees.
Yeah, he's in a list of attendees. Mark Billinghurst.
Yeah, you can move.
Everyone knows
you can move him to the panelist.
Good. Okay, welcome, Mark. I will introduce you formally. I think I have to start now. It's 5 minutes after time. Of course, I expected that we wait a little bit. So welcome, everyone. I would have loved to welcome you here in Utrecht. If I look outside, even the weather isn't that bad today. But yeah, we all know what happened. So welcome you from everywhere, wherever you are. Very nice turnout we have. So I'm really happy that you could join from everywhere all over the world, especially the ones in more challenging time zones. My name is Wolfgang Hurst. I'm one of the general co-chairs from this conference together with Philip Xu and Jeffrey Tsai. I think Jeffrey cannot be here today, but Phil is here. Phil, do you want to say quickly hello to everyone?
Hello.
I don't think they see you because I only shared my slides, but Phil is here and he's waving hello. If we have time in the end, then we can have a shared discussion and you can also talk. I will be opening this conference. We already had one session before, so it's weird that the conference is opened in a second session, but you saw in the program that the second session is shared with everyone because we have the keynote here. It's also usually you have the keynote at the beginning to open the conference. But the reason why we have this is, of course, because of the different time zones, because this is the time zone that matches the best in most places of the world, a few unfortunately not. That's why, of course, we also delayed the opening of the conference to now. And usually at the conference, it's kind of common that the conference chair gives a welcome, says thank you to everyone, says something about the paper statistics, the submissions, gives a general reflection on the status of the conference, and then a program overview. Now, I don't know about you. I usually enjoy this very much. I really like to hear also what's going on beyond those, beyond the scenes, how many papers were submitted and everything. But also after like seeing then 3 or 4 statistics, I'm usually also get quite bored very quickly. And if there is one thing that we learned in the last 9 months, then I think it's that you can get bored very quickly with if you have a Zoom session where you just see some boring statistics, which is why I will not bore you now, but I will bore you every day. So I'm splitting this over the different days, but in small chunks, and then hopefully it will not be boring. But one thing, of course, that I cannot delay is the thank you for all the people who made the program possible, who put it together. So I will go quickly through it, but of course, very big thank you to all the program chairs. One of them is also chairing this session. I will hand over to him very soon. And the poster chairs who are responsible for the poster sessions that we have starting tomorrow. Then the industry chairs who put together the industry session, which we will have on Friday. Saskia will also give an invited speech at the conference, should also be very interesting. Demo and video chairs who are also contributing to the poster session tomorrow. We also have 3 special sessions. The first one only did get 2 papers accepted, which is why we included them in the major program. But nevertheless, of course, a big thank you to all the organizers of them. The other 2 special sessions, one of them is after this one, and the other one is on Friday. Should also be both very interesting. And then also thank you to the people who worked behind the scenes. I do not mention all the names, of course, because this would be too much. But I want to mention two people because they will otherwise get not noticed, and those are the local arrangement chairs, Geraldine and Martijn from our university, because they had the worst job. They did a lot of work in setting up the event, only to be locally organizing location and everything, doing financials, only being told then in June, yeah, nice work, but we don't need it because we go virtual. So a huge thank you to them. And also a huge thank you to the team who stepped in there and did the virtual setup, Simon and Ivar, who are one current and one former students of us, and André and Florian from Darmstadt. So thank you for setting up. They set up mostly in the Mozilla Hubs environments, which we'll talk a little bit about after the keynote. So yeah, so like I said, I will say a little bit more about the program and why it is that way afterwards. So I've seen also already the program, but I also always find it nice to hear when I'm at the conference to what was going beyond it, what led to this program, and why did we make certain decisions. So I always find it nice when I'm at the conference and I see it's not just squeezed in everything that they had in one session after the other, but they put some thought into the program to make it also interesting for the attendees. So I will talk about this after the keynote then. I just wanted to highlight also the yellow spots here. First of all, that they don't get lost and that you also notice that there are parallel workshops going on. And secondly, of course, to also thank the workshops organizer for putting them up, because they also have some really nice programs, also nice keynote speakers and really nice papers. The first one already started in the previous session and will continue after the shared keynote speech about immersive analytics. The second one will be tomorrow. It's the second time that we have this workshop. I'm really happy that we have it because it's a workshop on ethics for AI and VR. And we all know that this is becoming more and more important and very relevant for this topic. And I'm glad that we much more have a technical focus here at this conference, that we have this workshop here to make the connection to the ethics community. So this is really great that we have this a second year. This is another workshop that we have for the second year about capturing and rendering to create digital humans, organized by Jaji, Fabienne, and Steve. If it's only getting half as good as the one last year, it will be great. I'm pretty sure they will make it better than half as good, but highly recommend it. And the same goes for this, for the other workshop that is also for the second time, the March workshop on modeling and animating realistic crowds and humans, which will then be on Thursday. And on the last day, I'm very happy that we have a new workshop, which is on medical imaging in relation to XR. So also a really nice workshop, really nice program that they put together. So highly recommend it if you're not attending one of the major sessions from the conference. Good. So the thing I didn't mention yet is, of course, I didn't thank yet are the keynote speakers. And I have to thank especially the first keynote speaker, because he is in one of the few countries for which this time slot is really not ideal, because I think it's 2:30 at night there now. And I have to admit, when I sent him the email to invite him, I did a calculation, how late is it? And I miscalculated, and I thought it's 11:30 at night. And then I thought, yeah, maybe he still wants to do that. Sent the email. Shortly afterwards, I realized it. Oh my God, I made a mistake. And I put in the email, it's going to be 11:30 at your place at that time. And then I immediately sent a follow-up. Sorry, it's very late at night. And then I immediately got a reply. Yeah, sure, I can do it. No problem. Thanks for the invite. And I'm like, oh God, he didn't see his second email, but he replied to the second email. So he was aware of what he was getting himself into. So huge thank you to Mark for agreeing to do this in the middle of the night. And also, of course, time for me to stop talking and hand over to Jonathan, who will appropriately introduce you, and then we will hear what I'm pretty sure will be a very great opening keynote. So I stop sharing my screen now.
Okay, thank you, Wolfgang.
And I see Marty's here, so I go on mute now.
All right. Hi, everyone. This is Jonathan Ventura from Cal Poly. Very happy to introduce Mark Billinghurst today as our first keynote speaker. So Mark Billinghurst is professor at the University of South Australia in Adelaide, Australia, and also the University of Auckland in New Zealand, directing the Empathic Computing Laboratory in both places. He's also Associate Director of the Australian Research Centre for Interactive and Virtual Environments at the University of South Australia, and Director of the Australasian Researchers in Interactive Virtual Environments Research Network. He earned a PhD in 2002 from the University of Washington and researches how virtual and real worlds can be merged, publishing over 550 papers on augmented reality, remote collaboration, empathic computing, and related topics. In 2013, he was elected as a Fellow of the Royal Society of New Zealand, and in 2019 was given the ISMAR Career Impact Award in recognition for his lifetime contribution to AR research and commercialization. He's truly a pioneer in augmented reality and virtual reality, and we're very excited to hear his talk about collaboration in AR and VR, very timely topic. And I understand there may be some Wi-Fi issues, so we'll hope that the connection works, and thank you for being here, Mark.
Great. So you can hopefully hear me okay, Jonathan, and everybody else.
Good, yeah.
It's really good to be here. As I was introduced, it's actually 1:30 a.m. in the morning here in Adelaide, but it's okay. I normally work quite late at night, so it's great to be able to join everybody. So let me just switch on my slides, and hopefully can do that fine. There we go. And great, so hopefully that's working okay. So what I'm going to talk about today is using AR and VR for next generation collaboration. And first of all, straight out, I should say that I'm happy to share these slides with any of you who are interested. So if you'd like a copy of the slides, please just drop me an email and I'll send them to you later on in the day or tomorrow so you can have a copy for yourself. And of course, this is all being recorded as well, so you can watch it later if you need to. So, of course, over the last few months, our workplaces have changed a lot. And you know, this is my workplace over the last few months. I've gone from working face-to-face to working a lot on Zoom. And of course, most of us have had the same situation where we spent hours and hours on video conferencing. And so after a while, it tends to feel like this. And it turns out this is actually a thing. It's called now Zoom fatigue. And there are many articles published about why we start feeling this Zoom fatigue. And it turns out there are three factors. One is physical factors. So, you know, if we spend many hours sitting in front of the computer screen, oftentimes we have poor posture, we work longer hours than normal. There's also cognitive factors. When you look at somebody on a screen, you lose a lot of non-verbal cues and eye gaze cues you have in face-to-face communication. So you need to concentrate more intently. And then sometimes people will be video conferencing at the same time on a second monitor. They'll be doing something else. Last time I taught a class, one of my students was playing a computer game at the same time as trying to listen to my class. So he was definitely multitasking in that case. And then there are also a number of social factors. Of course, when we're on Zoom, we oftentimes have a wall of faces all looking at us. And so we are very aware of being watched. And oftentimes, of course, you can see yourself as well. So that all those factors together add up to some social factors that cause tiredness. So these three elements, physical, cognitive, and social factors, mean that video conferencing is very different from face-to-face collaboration. Sometimes people try to get around this. This is my friend Dan Novi, and Dan is MIT Media Lab, and he decided to make Zoom meetings more entertaining by using augmented reality to dress himself up in these different meetings. So you can see himself there as Doctor Strange and Max and Where the Wild Things Are and this dancing video. And he said that was really great, except it had this counter effect that now people were inviting him to meetings just to see what he was going to look like when he attended the meeting. So kind of went against reducing his number of meetings. So teleconferencing today, of course, exists across many platforms. You've got room-sized teleconferencing, you've got the desktop conferencing on our mobiles, and even this iBeam device here where you can have this kind of telepresence robot that rolls around. But all of it is very different from face-to-face collaboration. So here's an example of some architects talking face-to-face, and you'll notice that they're talking about these building and plans on the table. So the task space is really this information that's on the table here. And then we have the communication space, which is broader than that, so it surrounds it. And in this case, people can oftentimes see their own communication cues while they're focusing on the task space. And I can see, if I'm at that meeting, what the person's pointing at or from face gestures. But when we start introducing technology into the mix, things change. So you can see here some people looking at a computer screen, and now the task space is very much on the screen, but the communication space is here. So you have this kind of disconnect. And even in large conferencing meetings, you've got here a group of biologists that are talking about some molecular biology, and this is the task space they're interested in. But here's the faces of all their colleagues, so the communication space again has this artificial separation. So some of the limitations of current technologies, we have a lack of spatial cues, that people blend with the backgrounds. We have poor communication cues with limited gaze and gesture and nonverbal communication. And we have this artificial seam between the physical and digital spaces and the separation of the task space and the communication space. So we want to look at how we can use technology to get around this. One way to do that is to bring 3D into the video conferencing environment. And there was this company called spaces.com that built a plugin for Zoom, which allowed you to be in VR and then use VR as a camera feed for Zoom or WebEx or Skype. And so then you can have a 3D environment into that space. So they were very successful, and actually just a few months after they started building this application, they got bought by Apple. So now their technology is no longer available. But my student built a copy of this, and so this is my student's work here. And you can see in the top left-hand corner, this is a standard Zoom call, but there's a window into a 3D VR space, and that's my student in VR. And because he's in VR, he can do things like pick up objects and move around the space. He has a collaborator in VR with him, and they can now have a lot more, communicate a lot more spatial cues than what they would if they're in a standard Zoom conference. And so now he's going to his workspace, and there's a whiteboard, and you can draw on the whiteboard and things like this. So bringing your body back into conferencing is actually something that I've been involved with for a long time. When I was doing my PhD at the University of Washington, they developed what was called the Green Space Project, which was the world's first tele-Pacific or trans-Pacific shared virtual environment. So you can see on the right-hand side in the green space, you had 4 people coming together, 2 in Japan and 2 in the US. And when you put the head-mount display on, you'd see a person sitting beside you in the right or left-hand side. And then a couple of years later, we developed one of the world's first AI conferencing applications. And you can see on the left-hand side here, we could use live video textures to bring remote people into the real world. And both of these examples provided increased spatial cues and improved social presence. Today, we have examples of online 3D conferencing. So this is me in a Outspace VR fireside chat a few months ago with my PhD mentor, Tom Finesse. And then you've got elements like Facebook Spaces, which are, Facebook Horizon, which is being rolled out in the US right now. And this is a large scale multi-user virtual environment that lets hundreds or thousands of people be together in the same VR space at the same time and use a lot of spatial cues to communicate with each other. So here's a short video of what Horizon looks like.
Beyond our world, there's another world. And it's right here, on my face. Welcome. This is Horizon. Think of me as your guide / self-appointed spokes avatar, here to show you around. You know, Horizon is filled with possibilities. You can play stuff, make stuff, fly stuff. Whoa! Really love the stash, Stuart.
What up, Stuart?
Wait, I want a mustache. Horizon isn't about rules or limits or pants or people telling you not to fly an airplane while drinking your fresh ground, fair trade, French press morning coffee through a curly straw. Isn't that right, Debbie? Mm-hmm.
Okay, so that's Facebook Horizon, and that's a very large-scale virtual environment. And you can see in that case, you're able to use VR to bring back some of the non-verbal cues that we have in face-to-face settings. But one of the limitations with Horizon, of course, it is all on VR. And so there's a company called Spatial, which has produced the spatial software that allows you to bring virtual people back into your real world and again share those same rich communication cues. But now, because they're in your real world, it feels much more like a face-to-face meeting. So this is a video of the spatial system working.
What if there was a better way to collaborate? A better way to build and work together? A way that brought us closer, as if we were sitting next to each other, face to face. What if our creativity could burst to life in the space around us? Spatial is a collective computing environment that lets teams visualize their thoughts in the room around them. So whether you're on a desktop computer or scribbling notes on your phone, all your digital devices are seamlessly tied together into an infinite workspace. You can manifest your ideas before your eyes by just saying them, and in a click, expand them with the power of all the world's information. Using augmented reality's infinite canvas, pixels become tactile, letting you manipulate them like clay. We believe digital and physical worlds should live in harmony together. You can sketch ideas out on paper or have them exist digitally. Spatial brings people and ideas together into a single shared environment.
Okay, so that's spatial, and you can see the great thing about spatial is it allows remote people to come back into your space, and then using augmented reality you can enhance that space and use it as a shared communication environment. And spatial actually works across multiple platforms, so there's a VR client, an AR client, desktop and mobile clients as well, so it seamlessly blends it all together. So one of the things with spatial and examples of augmented reality is that you can break those communication seams. So in this example here, you can see two people collaborating together, and they can use natural gaze and gesture cues, and they can, task space again can become a subset of the communication space. You can see here's a task space, and again they can see each other again. So one of the goals of video conferencing is to produce an environment which is as close as possible to being there as face-to-face collaboration. But about 20 years ago, there's a really great paper published by Jim Holland and Scott Stornetta called Beyond Being There. And this paper said that actually with teleconferencing, we shouldn't try and reproduce face-to-face collaboration. We should try and go beyond that. And it says a better way to solve the telecommunication problem is not to focus on the tele part, but to focus on the communication part and to develop tools that people will want to use even if they are face-to-face. So that's why things like spatial are so powerful, because with spatial you can use speech recognition to create images and objects that you might be talking about. And so people might want to use it even when they're face-to-face because it provides them the ability that they can't get in terms of communication. So one of the great things about augmented and virtual reality is that we can use that to go beyond being there. And we can do things that we can't normally do in face-to-face collaboration. Things like copying spaces or changing our body scale, copying our bodies, sharing non-verbal cues, changing perspective, and sharing views. And so in this talk, I'm going to talk a little bit about some of those things and then talk about what might be happening in the future. So first of all, changing perspective. One of the very early examples using augmented reality for remote conferencing was the CamNet system developed by British Telecom in 1992. And this had somebody wearing a camera and a wearable display, and then they would live stream video to a remote person who would then be able to annotate on the video and show it back to the person in their wearable display. And what they found was that by providing a wearable computing or wearable teleconferencing system like this, you were able to cut performance time in half for some physical tasks in the real world because you could have a remote person helping you. So in our lab, we built our own version of this, and so you can see that here this is a AR display with a depth sensing camera on top. And in this video here, it shows what you see in that camera. So on the left-hand side is the AR view, the right-hand side is a live feed to a remote expert. The remote expert can then draw on the live feed, and the person in the AR feed sees that drawing fixed in the real world. So this is a very easy way to do remote expert collaboration. And in fact, this type of system is developed by many researchers and is commercially available through companies like Microsoft. One of the problems with the system, though, is that if you have a camera on your head, you want to have a very wide field of view so you can see as much of the user's workspace as possible. When you have a very wide field of view, then what the person's looking at becomes more difficult to know. And so we built a system called the empathy glasses that was designed to be able to share gaze cues with remote people. And so this combined three pieces of technology together: a eye tracking system, an AR display, and a special pair of glasses frames called effective wear glasses that could capture your face expression. And the goal of this was to share some of the non-verbal cues that people have in face-to-face collaboration, like eye gaze cues or face expression. So here's the system all put together, and then on the right-hand side, you can see the view that the person sees in the head-mount display. So the green dot is very important. The green dot is the remote pointer from the remote expert, so they can watch the video, and then using their mouse, they can point at objects. And then the red dot is the eye gaze of the person who's wearing the system. So now the remote expert can tell if the person's paying attention or not, because the eye gaze will follow the remote pointer. And so this means now we can have implicit cues for remote collaboration. So here's a video of the system working. And what you'll see in this video is a person who's assembling blocks on the table, and he's live streaming the view to a remote person who is watching on desktop. And he's using, the remote person's using his mouse pointer to point at locations to move the blocks to, and you can see how the eye gaze follows along. So he can now tell if the person's paying attention or not, because he's looking at where he's pointing. And of course, people always look at objects before they move them, and so it's a great way to tell an implicit cue of what's happening. So we combine this with a heart rate sensor, and we have also this effective glasses that can measure your face expression using photoreflective sensors. And so that means now when people change their face expression, we can reflect that, and we can also show the heart rate back to the remote person. So when the person's feeling stressed or emotional, we can detect and represent that. One of the problems with this system, though, is that we still have a regular camera on the person's head. And so the remote person can only look through the local person's point of view. They can't see anything else. And so a year or so later, we developed the shared sphere system. The shared sphere system uses the live 360 video camera. So with this system, you can live stream 360 video to a remote person who's now in a VR headset. And so the person in the VR headset can look wherever they like, and they can see 360 video from the location of the other person. And in this case, the VR person also has a hand tracking system. And so when they put their hands in front of their face, their hands are captured and they are sent to the remote person. And the remote person now will see an augmented reality view of hands floating in space in front of them, which can then point at locations in the real world and guide them through tasks. And now, because both people could be looking in different directions, we also want to represent where they're looking. So you can see in the bottom pictures here, a green square and a red square. This shows the gaze of the two remote people. So this is the shared sphere system working. In this case, we've got a person who's in a power station trying to get some help with a power control panel. So he's wearing the HoloLens AR display and also the 360 camera, and the 360 view is live streamed to the remote person. So in the AR headset, this is what he sees. He sees those virtual hands floating in front of him, and the virtual hands can point at objects or leave annotations in the real world. And of course, they can talk to each other as well, so it's very easy for them to communicate and express which way they want to interact with each other. And this is the remote person. The remote person has the 360 video being streamed to them. And so to this person, it almost feels like he's standing in the same location as the person in the real workspace, because he sees a live video feed from that workspace. And so he can draw on the video, and then those drawings get sent back into the real world as an AR annotation. But of course, one of the limitations with this system is that you're streaming 360 video. And so the person who's in VR can look around and they can view the video from different directions, but they can't walk through the space, and there's no 3D model of the space. And one of the other limitations of this is it's very, very expensive. And so when COVID hit, and we decided we could use this platform technology as a way to also address the problem of tourism, and how, in New Zealand at least, and here in Australia, there are no tourists coming anymore. So we wanted to be able to provide a way for tourists to experience location remotely. So we took that very expensive shared sphere system and shrunk it down to what a consumer could use. So in this case, we have a 360 camera mounted with a tablet, and then this live streams to a web browser. And so the person now can use their mouse to pan around the web. And so this is the technology behind that. We used the Jitsi platform, which is an open source video conferencing platform, and we built a 360 camera plug into the platform. And we also added support for loading 360 recorded content or still images, so people could then get a high resolution view of what they're seeing. So this video here shows the system working. So this is in New Zealand. A person's going to visit the local museum, and as they walk into the museum, they can walk around and they can live stream from their location a 360 view to remote people on their web browser. So here's some remote people. And software will support streaming to up to about 20 or 30 people. So it's quite, and you can have groups of people going through the location, and then on your web browser, you can look around and pan around the camera. You can also load pre-recorded videos. This is a pre-recorded video that was captured beforehand. It's higher resolution. And you can also, and this is another video that's been recorded as well. And you can also load still images. So in a second, you'll see them loading up an 8K still image, which is also very high resolution. And so this combination of 360 video in the browser plus pre-recorded video plus still images means that you can now provide content that enables a tour guide going through museum locations to do some storytelling and tell people about the artifacts that they're seeing in the museum or in their location. So since we released, we developed that software a couple of months ago, we've done several trials, and we've had people react very positively. And even though they're not in a VR headset, many people still feel like they're in the location that they're visiting. But as I said, one of the limitations with this is that it's still 360 video. So most recently, we've done some work on 3D live scene capture. So it turns out you can get some depth sensors, some RGB cameras, and each of these cameras capture a cluster of 3D points, and then you can tile them together so that you can then and you can fuse all that point cloud, so you can create a live captured 3D object all in one go. So with this system, we can then capture the 3D model of the real environment and live stream that 3D model to a remote location. So the person in the remote location can now walk through that 3D model in a VR headset. So this video shows that working. On the left-hand side, you'll see a God's eye perspective. The right-hand side is a first-person perspective. And this is part of our lab. And so the person's in the VR feels like they're standing in the lab. And then on the left, you'll see in a minute one of the students walking into the space. And as they're walking through the space, we're creating a 3D model of them as they go through the space. And so now we can move through the space and we feel like we're really part of the 3D space. Of course, there are some limitations. And so wherever you see the blue there, that's where the cameras can't see. So under the chairs, for example, or a bit further away. And that table in the middle is supposed to be a flat table, but actually you can see it's got a wave going through it because our cameras aren't quite properly calibrated. But this shows how in the future you might have some sort of system that's tripod mounted that you can put into a location, and then you can live capture a 3D location, send to a remote person that could help you perform some sort of remote task. Here's another example of how that might work. This is we've got cameras placed around the table. On the right-hand side is a VR version of the real world. Left-hand side is the real world. And we've now got a person who's in VR trying to help you position objects. So that blue hand is the ghost hand of the VR person. He's telling the person how to put that yellow object down on the table. And as she places the object, you can see the yellow object appearing and moving in the VR environment as well. So you can imagine that in a few years' time, there might be small handheld devices where you can walk into a space, hold the device up in the air, and immediately capture a 3D model of the space and then start live streaming the 3D model to a remote location. So we've gone from 2D capture and sharing to 360 to now 3D sharing, and this provides increased immersion, better scene understanding, and most importantly, better collaboration. But once you've captured the world as a 3D environment, you can do a lot more things with it. So one of the things that we were interested in looking at is how we could add other communication cues. So in this interface, we had an AR-VR collaboration. So we had one person in the real world in an AR headset and a second person in VR in a remote location. And in the VR display, they saw an exact copy of the real world. So you can see in panel A there, these two avatars with pink heads. And then in panel B, they're now both together inside the real environment. And that's what we're interested in exploring, is how we could add extra communication cues. And in particular, in panel C, we added a view frustum. And what this was exploring was, normally in a face-to-face communication, you can't see where the other person's looking unless you look at their face. But in this case, even though I'm not looking at the person's face, because I can see the view frustum, I can understand where they're looking. So this video shows that working. On the left is the real world, the right is the digital copy. This is the AR view, so I can see my collaborator with me. And these blue lines coming out from his face, or pink lines in this case, show the view frustum of the other person. So this is down in VR. And now we are trying to do a collaborative task where we've got to find objects together. And so we looked at different conditions, having no view frustum, having a view frustum, having some eye gaze cues, and eye gaze plus view frustum. And so here's an example of the view frustum in VR, and I can see where the person's looking even before I see their face, because I can see this pink pyramid coming up from their face. And what we found was that by showing that virtual view frustum cue, we could significantly improve the collaboration, because now we knew where each person was looking. Once you've got a VR copy of the real world, you can start doing other things as well. And one of the very interesting things is multi-scale collaboration. So this is where you could change your body scale and make yourself bigger or smaller to collaborate at different scales. You might, for example, have a copy of a real location, and in the real location, maybe it's a emergency response. You might have a number of firefighters who are in the real location, and you might be the fire chief, and you might want to see where all the firefighters are. So if you make yourself really, really big, you can look down and you can see a world of miniature view of the location with all the firefighters in the location. So in this video here, you'll see an AR-VR collaboration again. On the left-hand side is the VR view, the right-hand side is the AR view. And right now, both people are at the same body scale. And so, but now the person in VR just made himself 4 times as big, and he's dropping objects in space, cubes and cylinders and spheres in space. And so the AR person sees him as a giant person towering over her. And then he's going to change his body back down to 1-to-1 scale. He's just moving some objects around, first of all. And so he changes back to 1-to-1 scale. And then he's going to shrink himself down to 1/10 the normal size. So now he's really small. And now he sees the person in AR towering down on him. And he can do objects at a small scale, like putting points down, things like that. And one of the interesting things, of course, you can do once you've got an AR-VR collaboration like this is that you can snap into the other person's viewpoint. So now you can virtually be inside somebody else's body, and you can see the world from exactly the same perspective. And we'll talk a bit more about that in a minute. So, of course, with virtual avatars, they provide a very important communication cue, but you can only see that communication cue when you can see the avatar. So you can see here, you've got 2 people in a mixed reality collaboration system, and they're both looking at virtual content on the table. When they can see each other's faces, they can see where they're pointing, and they have some rich communication cues. But in the second panel, the person in the grey shirt is standing behind the lady, and she can't now see his face expression or his hand gestures while he's pointing at that box. So we developed a system called Mini-Me, which basically makes a miniature copy of you, and when you can't see the other person, it puts a miniature copy of that person in your field of view, so you can always see their gestures and face expression even when you can't see their body. And this is really important, especially for current AR displays. So AR displays like the HoloLens, for example, have a limited field of view, only around 40 degrees or so. So that means it's very difficult actually to see a virtual avatar of the person you're collaborating with and the content on the table at the same time, because you can only see a small amount of field of view. So with the Mini-Me, when you look away from your remote collaborator, you'll see a little miniature avatar that appears that always stays in your field of view and points to the same real objects that the life-size avatar that you're collaborating with is pointing to. So this enables you to share rich gaze and gesture communication cues. So I'll show a video of this. I'm just going to fast forward a little bit in the video to about here, I think. No, back a bit, sorry. Okay, so this shows the problem with the person behind you, but with the Mini-Me, you can see now, even though she can't see the large avatar, she can see this little miniature avatar appearing in front of her, which is pointing to the same location. So the Mini-Me appears when you look away from a person. So there's a life-size avatar, and when I look away from the avatar, I see this little miniature avatar appearing, and the avatar now points to the same location as the large avatar was pointing to. When I gaze back, then the miniature avatar disappears and the large avatar appears again. And you can also do things like pin, mini, me, and location, so it's fixed in space. So the main thing we're trying to explore here is how we could now separate out, using an avatar for communication cues from using the avatar being driven by the real person. And then when we started exploring multi-scale mixed reality collaboration, it occurred to us that you could actually, if you've got I'll just pause this for a second, if you've got an avatar, a miniature avatar, you could attach it to a real object, and then you could drag the real object around and move the avatar around. So in this case, you see two video clips. On the left-hand side, there's a person in the real world who's trying to fix their PC. And in their hand, they're holding a small camera tripod with a HTC Vive tracking puck on top of it. And that represents the position orientation of the person who's trying to help her. And so when she looks at it, she'll actually see a little miniature person on the camera tripod. And on there's also a 360 camera. And so in the bottom right-hand corner, you can see the view from the 360 camera. So the person who's in the remote collaborator can then view the real world from the 360 camera view, and they can try and help the person perform a real task. But in this case, the person in the real world can drag their view around and position it to where it's most useful. So in this video here, you'll see she's trying to fix this PC. So she's holding her collaborator in her hand and moving him over the PC, and he can now see in the bottom right different parts of the PC. And she's trying to install a graphics card actually. So she puts him down on the table and turns the computer over, and she can then place him on the side, and she can then put the graphics card into the slot under his guidance. And so you can see the little person on the left-hand side who's looking around, and you can also see a view frustrum appearing there and showing what he can see. So they're able to collaborate together. And we did a study looking at what different types of representations we should have on the remote person. Should we have a virtual body, just a view frustrum by itself, or the two of them combined together, or no cue at all? And we found that combining the avatar and the view frustrum together produced the best collaboration in this case. And then one of the old projects I worked on a long time ago was looking at how you could use mixed reality to seamlessly blend real world and virtual world collaboration. So many of you are familiar with the mixed reality continuum, where at one end you've got the real world and at the other end you've got the virtual world, and in the middle you've got augmented reality. And oftentimes we build collaborative interfaces that exist as discrete points along this continuum. But if we use augmented reality, we can actually seamlessly blend and move our way along that continuum. So for example, we could have a real book that we're reading, and then using augmented reality, we could see a scene that pops out of that pages of the book. And then if we wanted to, we could immerse ourselves in VR and jump into the book itself and immerse ourselves in the story. So I developed, extended this idea for collaboration. And the Magic Book project, which was done almost 20 years ago now, looked at how we could use a handheld mixed reality display to seamlessly blend between the real and virtual world. So you can see two of us here reading this book, and because it's a real book, we can share it together and collaborate and read together. But then on the pages of the book, we can use augmented reality display to see graphic content popping out of the pages of the book. So in this case, we each use a handheld display. And then as we look through the handheld display, we can see AR content popping out of the pages of the book. And you'll see that in just a second. So in this book, it's the story of a Japanese princess, and here's the Japanese princess, and she pops out of the page book as an AR character. But every second page is a scene that you can fly inside and become part of the story and explore it as a VR experience. So this is this is her bedroom, and it turns out she's lost some precious treasures, and then in this book you're supposed to try and explore the scenes to help her find those treasures. So on this page you can see the farm of her friend Samurai, and you can then zoom into the scene and explore it as a VR environment. Now, of course, now one person's flown into VR, but the other person is still looking at the book as a real object, and so they can see the person in VR in an AR view. So you'll see that in just a second. So on the page of the book now, you can see that pink head. That's me moving through the VR scene, and the person is looking down at me in AR and seeing me in the VR world. And then, of course, to make sure the metaphor is consistent, when I look up into the virtual sky, I should see a giant head looking down at me collaborating. And in fact, you will see that in just a second. So I think now when I'm in the VR world, I look up into the sky, I see this giant avatar looking down at me. So this is very old now, I said 20 years old, but even today it's very unusual to find systems that support seamless blending between AR and VR. And of course, if we do this today, we'll have much richer graphics and collaboration. And then, of course, we can both be in the same VR environment together collaborating. So collaboration in the Magic Book occurs on multiple levels. As a physical object, as an AR object, an immersive virtual space, and it supports both egocentric and exocentric collaboration, and it allows people to have their own independent views as well. So I want to talk a little bit about what might be happening in the future, and some future trends around collaboration. And in my opinion, there's kind of three important trends happening. One of them is that we're moving from sharing faces to sharing places. So, as people are very comfortable with watching video conferencing, but now you've got people putting cameras on their heads and live streaming their surroundings, like I showed you before. A second trend is towards faster networks. And 50 years ago we used old rotary phones, but now we've got my apartment in Auckland has a gigabit fiber connection, so that I can live stream high definition video, and we've got 5G networks on our mobile phones, so we can live stream very rich communication queues. And then the third very important trend is implicit understanding. What this means is that systems can look at us and recognize our behavior and emotion. We've got cameras that look at our faces and understand how we're feeling. We've got other systems that can look at our bodies and understand what actions we're trying to perform. And even devices like Siri on our mobile phone, we can push a button, we can talk to it, and Siri will understand what we're saying. So these three trends are very important in terms of collaboration. So a very natural collaboration that's afforded by rich communication networks. Experience capture, we've got technologies that allow us to do 3D scene scanning or 360 scene capture, and implicit understanding. So these combine together in the area that we're calling empathic computing, and that's the focus of my research lab in Australia and New Zealand. And the goal of empathic computing is really to answer this question: can we develop systems that allow us to share what we're seeing, hearing, and especially feeling with others? So to some extent, when you put a camera on your head, you can easily understand what somebody else is seeing and hearing, but it's much more difficult to know what they're feeling, and that's where empathic computing really comes in. And so we've done a number of experiments in that place. One of the first things we did was looking at sharing emotion in VR. So we had a person inside VR wearing a special biometric glove that measured their heart rate and GSR, their sweat level. And then we had two people, one person who's playing a game and a person who's an observer. And the observer would basically be in the virtual player's body, but we would share the heart rate of the player with the observer to see if, when they got more excited, if the observer would also get more excited. And we tested a number of different VR applications. One was a butterfly game, it was very peaceful, and the second was a zombie killing game where you were in a very dark room, it was very scary, and these zombies were attacking you and you had to shoot them. So here's the video of this working.
In this research, we explored the effects of sharing physiological states of players in collaborative virtual reality gameplay. Our goal is to improve and enhance users' empathy among collaborators, especially in a remote setting using advanced computer interfaces. To support this study, we developed a collaborative VR framework which shares the player's position and heart rate to the observer in a virtual environment and rotate their head freely to look around. The player's heart rate is measured by a biometric glove. The measured heart rate is shared with the observer using both visual and audio cues. We developed two games based on this framework. The first game provides a calm and pleasing experience where the player catches butterflies while surrounded by nature. The second game presents a scary and stressful situation where the player tries to survive zombie attacks. We conducted a study to learn the effects of displaying the player's heart rate to the observer. From the insights gathered in this study, we present a set of guidelines for designing collaborative VR experiences.
So in that paper, we basically looked at how showing heart rate would influence the other person, and we found that when we share the heart rate, so in this graph here, you can see the blue graph is is when we're sharing the heart rate, and the green is when we're not. When people were having positive affect feelings, showing the heart rate further increased that further and made people feel a lot more positive towards the other person, and so it resulted in a higher affect score, and it will also cause more collaboration between collaborators. So that was very interesting. Of course, there's a lot more research in that space in terms of how you can share the heart rate. And we found that people really didn't want us to actually see a beating heart on the screen, but hearing the heartbeat sound, and especially with the VR controllers, we can cause the controls to vibrate and feel the vibrations, which was a really powerful experience. So there are a number of technology trends, which I think many of you are aware of, trends towards advanced displays, towards real-time scene capture, natural gesture and gaze interaction, eye tracking. And one of the trends that I'm particularly interested in is emotion sharing and sensing and sharing. And so we're starting to see VR headsets coming to the market now that combine other sensors into the headsets. So for example, this is a Lucid Link. The Lucid Link is a face pad for the HTC Vive that allows you to put 6 electrodes on the face, into the face pad, and then measure people's brain activity on the forehead and directly stream that into a VR experience. A variation of that is the NextMind system, which is a set of electrodes you can on the back of your head, and you can attach it to a VR headset or an AR headset. So here, for example, is a person using the NextMind. And you can see in this case, they're playing a game where they just look at these aliens, and then when they concentrate with their head, it will cause the aliens to explode. So they're able to measure overall concentration levels and use that to control games or other VR experiences. And in the next few months, Hewlett-Packard is going to release the HP Reverb G2 Omnicept, and this is a wide field of view head-mount display that combines eye tracking, heart rate detection, pupillometry, and a face camera all into one package. So now you can imagine using this headset, you could go into a social VR environment, and using the face tracking camera, you could have an avatar that exactly maps onto your face expression, and you can also measure people's heart rate, and so their stress level using the heart rate pupillometry or what they're interested in by looking at the eye tracking. So this will be able to enable us to build a wide range of physiological based experiences. In our own lab, we built our own versions of this. So this is one of the systems we built, and we basically took a VR headset and combined it with an EEG cap and also some EMG and EOG face pads that can measure face expression and with a heart rate sensor, and then started using physiological data into our VR environments. And one of the things that we're really interested in is brain synchronization, especially because it enables us to know how other people are feeling. So brain synchronization is a relatively recent phenomenon that's been explored. And what people have discovered is that when you have 2 people wearing EEG brain caps, when they do a physical task, in this case they're pointing at each other and they're moving their hands around or tracking their fingers, when they do this task, sometimes the phases of the EEG signals will become in sync. And so, and when this brain synchronization occurs, then people report that they feel more connected to the other person, they feel like they can collaborate better, and they perform better on collaborative tasks. So this has been studied for about 10 years in the psychology community with a wide range of face-to-face tasks like physical motion, gameplay, conversation tasks, and negotiation tasks, and so forth. But what shows typical results of an experiment done with the brain synchronization. Here you can see, and this is a finger pointing task, you can see the 2 heads of the people in the experiment, and the black dots there represent the EEG electrodes. So this is before they started the experiment, and then you get them to move their hands around, tracking each other's fingers, and then you get them to stop. And when they stop, you see this behavior. What these arcs show is the electrodes that are in sync with the electrodes on the other person's ahead. So this is really amazing. This basically means that your thoughts somehow can interact the other person and can impact the other person's thoughts, and the brain activity of both people come into sync. So this is a really interesting phenomenon, and we've been interested in studying this in VR. So this is a VR version of brain synchronization. So we have two people sitting in VR wearing the EEG headsets, and in this case, they are looking at each other, and they represent by an avatar, and you can see now they're doing a finger tracking exercise where one person moves their hand and the other person tries to track the fingers around. And when we did this, we found again the brain synchronization would also occur inside VR. But of course, because it's VR, we can do something else, and that's we can put one person inside the other person's body. And so here we have two people inside the same body. And so I look down and I see two extra hands coming out of my body, and then I try and follow that hand around. And what we found again was brain synchronization happened, and even more extremely, because now we're both sharing the same viewpoint. So this is what the two brains before the activity starts, and those lines there show electrodes that are show some phase synchronization, but in this case, there's a relatively low level of connection, and most of this data is just because of randomness. But when we go into VR and we are looking from the first person perspective and we do that finger tracking task, then we see this, and you can see now the lines are much deeper red and much fatter, showing that there's much greater number of connections between the electrodes. And we're really interested in using this as a way to enhance collaboration between people. So last year, we developed this experience for SIGGRAPH Asia, and it was basically a drumming experience. And as you were drumming inside VR, because drumming is a very rhythmic activity, we could measure your brain activity, and as your brain activity got in sync with the person across the table, we provided additional VR cues. So when you started drumming, you would see a live video feed of the person across the table. But as your brain got more in sync, we would change the visual effects and make the person across the table disappear and add more particle effects and graphics into the experience. So I'll show you the video of that running.
Is a VR drumming experience that allows two players to drum together while their brain signals are simultaneously measured. At first, you can set some daily objects on a table to use as drums. The player will use two drumming sticks to play the game. Both of the players will wear an EEG capturing hardware to get their brain signals measured from the frontal lobe. The data acquired will be streamed to the data processing system to enhance VR experience, depending on the player's collaborative performance. We designed a software to calculate the phase locking value, which is an index of neural synchronicity, for the FP1 and FP2 channels of the data band from both the participants. When synchronization between two players is low, the camera will be more clear to do so, whereas when synchronization is high, the vision becomes more obscured, with each point cloud eliciting higher particle effects. We logged and analyzed the user's brain signals.
So we showed this at the SIGGRAPH Asia conference last year, and about 500 people tried it during the conference, and we measured their responses, and we found that people who were more in sync with each other felt that they had a better collaborative experience and they could perform better. So you can see what I've shown you today about is this kind of technology trend towards combining a combination of advanced displays, capturing space, gesture and eye tracking interaction, and emotion sensing, all combined together to what might be called empathic teleexistence. And the idea of empathic teleexistence is that remote people move from being observers to being participants in each other's environment. And communication moves from being explicit to implicit communication. And overall, you get a feeling that you're doing things together. And the extreme of that might be what was shown in this movie called Surrogates. And Surrogates was a pretty bad movie that was filmed about 10 years ago. But in Surrogates, the idea was that in the future, you would experience the world through another body and through a robot. And you'd have a VR interface, and you would go into VR, and then inside the VR, you would control these robots in the real world. And because they're robots, they can do things you wouldn't normally do in the real world, like jump off buildings or fight people or do very dangerous activities. but you'd never be able to be hurt because you're inside the VR. So in this movie here, I'll play a little bit of the short clip you can see here.
Robotic human surrogates combine the durability of the machine with the grace and beauty of the human body. With most people living their lives through their surrogate selves, our world has become a safer place. Take a seat in your STEM chair.
So here's Bruce Willis, and Bruce Willis is going to go into the VR environment, and this is the Bruce Willis robot. You can tell the robot looks younger and has a full head of hair compared to Bruce Willis, and now he can walk around the real world and do things like jumping off buildings and things like this. And in the movie, you know, everything's really great, except eventually these robots start getting killed or destroyed, and now for the first time, when the robot gets killed, the person in the real world in VR starts dying as well. And so it becomes a murder mystery movie, and Bruce Willis has to try and solve the mystery. It's not a really good film, but the sci-fi premise is kind of interesting. And you might think this sounds very much like science fiction, but actually companies are trying to make this for real now. So there's researchers in Japan and other places that are building these empathic teleexistence robots where you can go into VR and you can inhabit the real body of a robot. And by having stereo cameras and stereo microphones in the robot, you can see what the robot's seeing and you can hear what the robot's hearing. In particular, there's a company called Teleexistence, which is doing this for real. So you can see this interface, he puts the VR headset on, he goes into the Teleexistence robot, and the Teleexistence robot is in Hawaii, and he's trying to buy a surfboard. So he's pulling out or showing the guy which surfboard he wants to buy. Then he can feel the surfboard, and because the VR gloves have tactile sensors in them, he can feel the gloves, and he can then take a selfie with the board. And then his son comes down and wants to join him and go somewhere, so they look at and they decide they're going to go and visit Kyoto to see the cherry blossoms, and so they can go into robots and look at the cherry blossoms. And then once they've done that, they decide they want to go even further afield, and now they're going to go into space, and they click the button, and now they're at the International Space Station, and they've got robots floating in space, and they can now look around and see the world from outer space. So this might seem like science fiction, but Teleexistence is a company that's producing robots now. They're very expensive, more than $100,000 per robot, but the idea is not to buy the robots, but to rent time on them. So for a few dollars a minute, you can rent some time on the robot, and you can try and be anywhere from inside your VR headset. So just to wrap up, I've talked a little bit today about how current conference situations has a lot of limitations, and over the last few months, most of us have been in an unwitting experiment where we've been forced to spend hours and hours online. And then AR and VR enable us to go beyond being there by changing our perspective, by sharing our space with other people, by supporting rich nonverbal communication cues. And there are many directions for future research, and in particular in my lab we're exploring this area of empathic computing and looking at how we can share people's feelings with others, enable them to have this movement towards an empathic teleexistence experience. So that's everything I wanted to say today. As I said before, I'd be happy to share the slides with you. If you're interested, just drop me an email and I can share the content with you. And I'm happy to answer some questions now. Thank you very much for your time.
Thank you, Mark. That's fascinating. So we do have some questions in the Q&A, and I encourage everyone to post your questions to the Q&A on Zoom, and I can read them out. I think we have a first question from Wolfgang, actually. Wolfgang, did you want to ask your question?
Yeah, let me just unmute and add my video. Thank you for this great talk, Mark, which was, of course, also a perfect opening talk, because virtual meetings and collaboration is, of course, also quite related to what we're doing here.
Yes,
do you have any prediction about how you think that future conferences will look like, both based on your research, but also on the experience that I assume you have from various virtual events you have attended in the last couple of months?
Yes. Well, it's a great question. so some of the things I've shown you, like for example, the spatial software, this is really good for supporting small group meetings where you've got 5 or 10 people together. But supporting larger conferences, like a few hundred people, is much more difficult. But I think what you'll see happening is people are starting to explore ways you can combine spatial, visual, and audio cues to support those larger events. In particular, one thing that's missing with these Zoom-like events is the kind of serendipitous meeting where you can bump into people in the hallways of conferences, and you can have chats over coffee, or you can accidentally meet people at lunchtime. And so some people are starting to explore that now. One of the things that's really impressed me is the work of a company called High Fidelity. And High Fidelity have made it's basically a 2D conferencing environment. So you go onto the web and they have a 2D conferencing space, and everybody has an avatar that's looking top down. But what they've done is they combine that with a really rich spatial audio. And so when you're in the space, you hear the audio cues from just those few people standing around you, and then you hear this kind of low buzz from everybody else. And as you move around the space, you can hear snippets of audio from people around you. And that works really, really well for large-scale conferences. And so I think what you'll find in the future is that, well, first of all, I think, in a year or two, we'll get back to having face-to-face conferences. But I can imagine even when we've got face-to-face conferences, there'll always be a hybrid element where remote people will connect in. And then I think you'll have tools like the High Fidelity or other tools that'll allow you to bring back some of the spatial cues and those accidental meetings that you have that you're missing right now. We ran the ISMA conference about a month ago, and we used the Verbella software, which allowed us to have hundreds of people as 3D avatars walking through space. And it was really great. We had a party in the conference space that worked out well. We were able to play soccer together. There was a beach party at the end where we watched fireworks together, and you could race speedboats on the water. So it felt a little bit like being really there. So it was not quite there, but much better than just having a Zoom event.
It's definitely hard to imagine doing something like this, a graph demo session, but I know we'll get back to it someday. Okay, we have some questions from the Q&A. Vinoba writes, fantastic talk, Mark. The multi-scale work and the mini avatar work are wonderful examples of what collaborative social XR spaces can look like. Were there user studies conducted to see what task performance was like? And are there papers out there for us to go find out more?
Oh, yes. So for each of those videos I showed, there were 1 or more papers that we published that looked at user study results. And so if you email me, I can send those papers to you, or if you just go to Google Scholar and look at my name, you'll find them as well. But we basically found that in a multi-scale environment, being able to change the body scale was one way to increase the situation awareness, and then to help on tasks, especially tasks that involved a expert novice kind of roles where different people have different roles in the task. So there's definitely a lot of studies done in that space. Also studies around what type of visual cues you need to share to help improve collaboration. Is it important to share gaze cues or pointing cues, or do you need a virtual body to be able to collaborate effectively?
Excellent. Okay, Gang Lee writes, for the empathic computing, what do you think of the EEG brainwaves in VR applications? My concern here is even though EEG seems powerful in emotion or cognitive assessment, it requires the participant to avoid motion artifacts. It seems contrary to the nature of VR applications.
That's a great question too. So, so there's been quite a lot of work done in EEG in VR. Most of that work has been about using EEG for brain-computer interfaces, so controlling things in VR, like the video I showed you from NextMind, where you can play a game. That's not so much what we're doing in our work. In our work, it's more about using EEG to recognize brain activity and then share with somebody else. But the most recent EEG systems we found can actually withstand a fair amount of body motion. So we've got some new systems from companies like M-Brain Train or GTEC, and these are wireless EEG systems, and these systems you can actually move a reasonable amount without getting too much noise. Anatole Lecure from INRIA has done some really great studies about how much people can move when they're wearing an AR headset or a VR headset in EEG before the noise signal gets too much. And he's discovered that with a moderate amount of motion, you can still detect the EEG signal relatively accurately. So I think for many VR applications, it's just fine. And then part of it also depends on how where the EEG is measured from. So for example, with the Lucid system, because you've got the EEG electrodes in the faceplate and it's pushed hard against the skull, when you're wearing the VR headset, that means you can move quite a lot because you don't have any movement of the electrodes themselves. Whereas when you're wearing a brain cap and a separate VR headset, as you're moving around vigorously, the brain cap may start shifting a little bit, or the VR headset may start rubbing against the electrodes, and that may cause some noise as well. So modern EEG electrodes, I think, are just fine. And in fact, we're doing a project now in our university to look at how we can build fabric-based electrodes. So instead of having solid metal electrodes, we use conductive fabric, and we're trying to put that into a headband that you have to wear tight on your head and be much more comfortable than wearing the full cap with metal electrodes in them. And this type of headband should be very noise resistant to movement because it's very tight on the head as well.
That's interesting. Yeah, they'll probably incorporate these into headsets someday.
Oh, definitely. Well, Lucid are already basically doing it, and with our system, if we get it right, we can put the electrodes into the elastic webbing that you've got on head mount displays already.
Wow. Okay, Abdallah El Ali writes, great talk, thank you. From the studies where you looked at users sharing their physiological signals and or reported emotions, was there any reluctance due to privacy, for example, identifiability concerns from such signals, or were the benefits of sharing more valuable overall?
Oh, that's a really great question. So in our interface, in our work, we haven't addressed the privacy issues a lot, but you can imagine there's huge privacy potential issues. So for example, if I had a device that was able to measure when I was stressed or not, or even when I was lying and I went into a meeting with somebody in VR and the other person was able to read the signals from that device and know whether or not I was feeling stressed or if I was lying to them, that would have huge implications on the meeting. So I think there's definitely a lot of concerns around that, but these are some of the same concerns that are being addressed by, with the activity monitors we wear today. If you have an Apple Watch, the Apple Watch can detect your heart rate, and it might detect if you have an abnormal heart rate. And if Apple starts sharing that to your insurance company, then maybe your insurance premium will change because your company thinks you're at risk of having a heart attack. So there's huge implications around privacy, and we haven't addressed that at all in our research. I think that's a really important area to be studied by somebody in the future. Most of the research we're doing now is assume that the people who are sharing the physiological data have changed their privacy settings or have allowed somebody else to see that data. So I might be happy to share my physiological data with my wife, for example, or if I'm working in a stressful occupation like a firefighter or emergency responder, then maybe I'm happy to share a certain amount of data with my employee so they can know when to help me because I'm feeling stressed. But yeah, that's a really good topic to study for the future, I'd say.
Absolutely. Okay, another question from Trayan Lavrick. Hello, Mark. Thank you very much for sharing your incredible research work with us. My question is, what are, in your opinion, the most important challenges that AR should overcome in the next 5 to 10 years from now in order to be adopted at a large scale in the industrial context?
Well, I guess it's interesting to say industrial compared to consumer, because in the consumer space, you have a lot of social considerations. If I'm wearing an AR headset that makes me look stupid or is ugly, I'm not going to buy that. But in an industrial context, people are more willing to put things on their head that they will use for short periods of time. And already Microsoft and other companies are deploying tens of thousands of AR headsets into the industrial context. So I think some of the big challenges are a couple of things. So one is being able to develop intuitive interfaces that are easy to use. Secondly, I think we have to have validated use cases that show the value of using AR. And some of that's coming now, but it still needs more. If you have to convince somebody to spend $5,000 for an AR head-mount display, then they need to be able to know that by buying that, their employees will work 20% more effectively or reduce the error rate or whatever else. Another challenge is standardization. And so right now, each manufacturer builds an AR or headset. Oftentimes they have their own development kit to code for that headset. And if I write an application for one person's head-mount display, it won't run on other people's head-mount display. So it's almost like having apps that only run on a particular brand of mobile phones, which is kind of crazy in the future. So I think that's a big issue to be resolved as well. And of course, in our research, one of the huge opportunities we see is in the collaboration space, but there's still a lot of challenges to be addressed in that space. So I think if you're able to build good collaborative systems, you might get to the point where people will be able to help people globally in a remote expert way, and you wouldn't need to travel to locations to solve or help workers work at those locations, which would have really big implications for climate change, and also in this COVID environment where you can't even travel, help address some of those concerns as well. So there are a lot of things have to be solved before AR is more widely used in industrial context. But I think what you're finding is that there are now validated use cases happening, and that's going to help drive the uptake of AR headsets more, and then that'll also flow into AR in the consumer space as well, much the same way as the first brick mobile phones 20 years ago led to the cheap mobile phones that we have today.
So those are really good ideas. We had a question from an anonymous attendee. You mentioned about the firefighter example of viewing objects as a giant scaled avatar. How is that possible to get a view of the objects from up there in live in real time?
Sure. So you can imagine a scenario where you have people going to a building. So maybe it's firefighters or emergency responders. As they walk into the building, each person is wearing some sort of tracking technology, so we know the location of the building. We also know beforehand, we somehow got a 3D model of the building. Maybe we flew a drone through the building beforehand and made a 3D model, or maybe there's a model on file. So now we can combine the location of the people in the building with the 3D model. And then if I make myself really big, I can combine them all together. And maybe we use a drone that's flying over the building to provide some oversight into the people here or something like that. But it's not that difficult to be able to track people in interior spaces now, or even over large spaces, and then provide a live feed of their location to you that can be observed in a VR environment. One of my friends, for example, is in New Zealand, is building a system that puts cameras into soccer stadiums, and they can track all the players that are running around the soccer stadium in real time. And so it's relatively easy to live stream that into a VR environment, and you can have somebody else who's a very large body looking down and seeing the entire football game playing out in front of them. So a number of technologies you can use that can be used for creating a type of experience.
Yeah, that makes sense. I have a question, and then I think we might need to wrap up. I was wondering, with your studies or using these kind of technologies, if people describe sort of the uncanny valley effect. I've tried some of these things in the headset, and talking with people, but I feel like I'm talking with a ghost or something. It's kind of spooky. So I was wondering where we are with that, and if you think that's an issue.
Oh, it's definitely an issue. I think there's several things. So first of all, if you're representing remote people as virtual avatars, then you do definitely get that uncanny valley effect where they start looking more and more realistic, and then suddenly something snaps and they look less realistic again. I think that's why companies like Facebook with their Horizon platform are deliberately making people look kind of cartoon-like, because they want to make them kind of recognizable, but not so you look like kind of soulless individuals. One of the most important things for remote collaboration is to share rich audio. So even if then you can kind of fill in the gaps, basically. Then the second element of that is, in our research, we're trying to do capturing of real spaces, and you have a similar effect if you can't capture the real space in a high enough level of realism. So we're trying to look at how we can do that more realistic. And in particular, what we're looking at now is using machine learning techniques, so that from the point clouds we're capturing, we can then use that to replace the point clouds with photorealistic content that we've captured from the real world that is at that location. So if we go through an environment beforehand and we capture photographs of that environment, then later on when somebody's in the same environment and we've got a point cloud, we can replace pieces of the point cloud with a photorealistic 3D model, and that helps get over some of that uncanny valley effect. But that's still an important area to be researched, and especially when you're representing remote people. Do you have to represent their face expression accurately? Do you have to show their gestures and their voice in order for people to have that social connection?
Yeah, a lot of good computer vision problems there, AI problems.
Definitely, for sure.
Yeah. Excellent. Okay, I think we should wrap up now in interest of time. Thank you, Mark, for that fantastic keynote and all your answers to the questions. I hope you can get some sleep now.
Well, thanks for the opportunity. And as I said before, if anybody's interested in the presentation, just send me an email, I'll share it with you. And of course, you've got the recording as well. It's been great to see you all, and it looks like you've got a fantastic conference ahead of you for the next day or two.
Thanks, Mark.
Great. Okay, thanks a lot. See you later.
Good. So should I will take over now, but Jonathan, are you done, or should I talk?
Yeah. Go ahead.
Okay,
go ahead,
good. You're waiting for me. Good.
Yeah.
Yeah, I will. Let me share. Here we go. Share my slides again. I want to give a few closing remarks for this session. Like I said, usually you say this at the beginning, but of course, in this case, it makes more sense to let the keynote speaker speak first. And I also don't want to go into the details over it. I don't want to go through the whole program. You saw it all online, so why should I do that? What I want to do is to give a little bit of background information on the program, how it came together. So like I said, we have special sessions. One of them is following right afterwards, and also the workshop on immersive analytics is continuing. We also have industry session on Friday, so it's pretty clear because those were in the calls. So it's clear that if we have an industry paper track, that we have an industry session and special sessions. These are the paper sessions based on the short and full papers from the first paper deadline. And so these are the main technical papers or scientific papers of the conference. The thing I want to say here in this context is a little bit about the topic of the sessions. Of course, tomorrow is the best paper session. That's pretty clear that we have that, or that's pretty clear what that is or why it's called that way. This morning we had an AI and VR session, which is already might sound a little weird. If we have an AI and VR conference, aren't all papers AI and VR? But the point is, of course, we are a very new conference. We are growing, but still at a good size, I think, but still quite small. So it's a new conference, so we have to establish a new community. And Phil, the other co-chair, also always says that conferences are not just about the presentations. Conferences are about meeting people, making connections, building communities. And this is, I'm going to talk a little bit more about this maybe tomorrow or no, on Thursday, about the whole conference, how we see it, where we place it. But for the papers, of course, we also said, if we want to bring AI and VR together and create a new community, if we're only accepting people who are working already in AI and VR, we're not creating a new community because they already exist. So we should be open also for people who are working in VR but are interested in AI, and people who are working in AI and are interested in VR. And that's why we said in the call, you can also submit papers that are only from one side, as long as it would be of potential interest from people from the other community. And this is why you have these two different sessions here that are mostly VR sessions and AI sessions. And also one of the VR papers actually that is more a typical paper you would find at a VR conference also made it in the best paper session tomorrow. So also, you know, when you hear that, why it's in the best paper session of an AI VR conference, although it's mostly VR research, but very great research. So that's why it ended up in the best paper session. Good, then the other thing I want to talk about is the poster session. And this fits really nicely to Mark's talk also. Because of course, yeah, we were thinking also when we had to go virtual, how are we going to do that? And there are two things I often hear from people or heard from people when I said how we're doing it. The one was, why are you making Zoom presentations when you're a VR conference? Why are you not using a VR environment? And the other comment I heard is, why are you using Mozilla Hubs? There's so much more sophisticated and better VR environments because Mozilla Hubs is web-based. That's why it's rather simple. But the answer is, Mark perfectly gave the answer in his talk. I actually wrote it down, so I'm not misquoting it. He quoted his paper that said, we shouldn't try to recreate face-to-face communication, but we should try to go beyond it. And he mentioned ISMAR also. I was actually there at ISMAR, and I enjoyed it a lot. It was really great. But they had this VR environment, and at the beginning, I went into one of the tutorials, and all the seats were blocked. And then I said, okay, I look at sat down in the back, and then I was like, okay, this is like in the real world. The room is blocked, you sit in the back, you hardly see the speaker, you cannot read the slides very well because you're too far away. So are we just recreating a bad situation from a real world and trying to simulate that? Why are we not trying to do it better? And this is, of course, one of the reasons why we said Zoom for presentations. Zoom has worked quite well in the last couple of months. That's why we stick with the Zoom site for the presentations. But for the for the posters, of course, Zoom, you're forcing then a format onto a presentation that is not really useful, that it's not intended for. And that's why we said, and also we're going for Mozilla Hubs, because Mozilla Hubs, as limited as it is, but it allows poster presenters and demo presenters to present their work not just with a poster. And this is then not just recreating the real world, because in the real world, you have a fixed poster board. You have to bring the poster there. So it has a fixed size. You cannot bring fancy equipment. In VR, we can do everything. So we encourage the poster and video and demo presenters also to not just show posters, but to do all kind of other things. And we kind of hope we encourage them also to do that by having then also a best presentation award. Actually, we have one for each day, because otherwise it would be unfair, because the people on the last day can see how people present on the first day and then try to make it even better. So we will also have a presentation award. So based on taking best advantage of the opportunities that VR and Mozilla Hubs offers you to present your work. So not based on the content of the work. That is, of course, good for everyone because they were all evaluated. So yeah, so this is a little bit an explanation of not what we're doing, but why we're doing it. And of course, also an encouragement for you tomorrow to go to the demo and poster sessions. So they're still setting up, which is why the links are not online. Tomorrow, then, when this conference starts, I will put links to all the hub rooms online. Mozilla Hubs has the unfortunate limitation that you can only have 25 people in the room, and even with 25 people, it's you have sometimes performance problems. But we have it split over the days that there is one person per one presenter in each room per day. So that should then work out quite well. So we'll have that online tomorrow. Just want to make the hint also, information on how to get there and how to use it for the people who have never done it is on the website. So all information about access, also linked to the Slack account that we're using for communication for the conference, is on the website. So this password protected website where you also find the program and the links to these rooms. Good, that is, let me stop the sharing now, because that is a quick overview or the big comments I wanted to give over the program. Do we have some final comments, questions, anything? So normally, if not, I would give it back to Jonathan now to end the session, but there isn't really much then ending it. Do you have anything more, Jonathan?
No, thanks to everyone for your questions, and yeah, looking forward to a great conference.
Good. So this is really one thing that is missing, the virtual applause.
Always very quiet on Zoom.
Yeah. Good. Then the session is over. We are going to keep this room for the next session. So we have scheduled 15 minutes break. We went 2 minutes over time. So yeah, all right. 5:30 is the next session. So we're going to set it up. It makes no sense to close the room and then make it private again and then invite everyone in. So everyone who is listening, we're just setting it up. You can listen to us or turn down the volume and get some coffee and then come back later. Good. So Yanquan is also saying goodbye because in Japan it's really late. Thanks for chairing the first session, Yanquan, and good night. Have a good sleep. You really deserve it. Mark, is she already panelist? No. Can Chuzeng, can you make Mar Gonzalez a panelist?
Okay.
And then also make her co-host because she is going to chair the session.
Make Mark as a co-host.
Yeah. First of all, now please stop the YouTube stream and then stop the recording.
Okay.